Welcome back to this machine learning playlist. This is day 17, and again, we are looking at another end to end project. This time, it's with the Airbnb uh, India dataset. So, we have already come across many of these steps. Let's quickly go through the project workflow. So, we define the project goal with respect to price prediction on an Airbnb Indian listings, and we have a data set which we are going to use for that Indian Airbnb data set. We are going to do pre-processing steps such as missing values, remote duplicate screen, inconsistent columns. Exploratory data analysis and feature engineering is something that we are going to do with a lot of graphs and visualizations. So we are going to start off with a simple linear regression and also compare it with other models such as random forest and decision tree, and evaluation with hyperparameter tuning and mainly measuring with MSE, RMSE, and R square values to tune parameters. Finally, we are going to look at how we can save this model, test for some unknown data points as well. So that's a quick rundown on this specific project. Let's quickly start on this. So here we have some basic import statements: Pandas, NumPy, Matplotlib to plot graphs, Seaborn, Pathlib. So we are going to start off with few import statements: train split, column transform, simple imputer, which we are going to use later, gradient boosting regressor, and all of these. So we are keeping all these imports ready. So here we start off with importing an Airbnb dataset, and the way that this dataset looks like is it has an address and is hosted by superhost, meaning say an Airbnb hosts this specific property, or a local host or a private person hosts this private entity hosts this property, right? So that's a meaning on it: location of latitude, longitude, name of the host, and number of guests that can be accommodated per night, and pricing rate or amount for per night, room type, and the number of stars. Here we see some missing values here. So that's something that we are going to pre-process. So data processing and pre-processing step. So we have all of these columns, and we see all of these unique values, and some of them, all of these have showing 500, also should give us a knowledge on there are 500 rows and about 9 columns, right? So yeah, that's about it. Stars, if you see there are less number of stars or there are missing values in the stars column, so we are going to fill it up. Yeah, so exploratory data analysis and feature engineering. So one of the things that we are going to start off is we have a set of charts that we are drawing, and before anything we have a Pearson correlation uh, method that we use to establish relationships between features and the target price that we are looking for, right? And also certain column names that we are going to assume that and we are going to plot charts with the same. This is with distribution of rental price and distribution with respect to guest rating and price, proportion of listings hosted by superhost and how the price is affected, rental price and guest rating, how that looks, and room types and how it affects price. Rental prices by room type. So yeah, geographical spots of these listings is something that we are going to plot with scatter map box plot. This is going to be an geographical map kind of a plot where each data point is going to be pointed out in the actual map. So distribution and accommodation capacity and how it relates to price. That's one other feature. Accommodation capacity and rental price. So yeah, these are few set of things that we are going to look at. Here, if you see, um, so one of the things that we see right off the bat is none of the features have a good quotient to measure price or rating. Many of it depends on location, location is one feature that helps in predicting the price, and also uh, stars also has a very less value, but location and latitude longitude has a location has a greater precedence with price. So we see distribution of rental price and the frequency. So there are about uh, frequency with of bookings are more in price range within 400 to 600, and others have a saturated kind of distribution where we see an highest at 400 rupees and 500 rupees being the second lowest, and next is with respect to somewhere around 450, and next set of things would be 500 to 600 having frequency less than 40 or close to 37 or 36. So distribution of guest rating, many of the values uh, have a guest rating of 4 and above, and largely 4.5 up to 5. That's the value that we have in our data set of 500 rows. And property listings, a lot of properties are listed by non-superhost type. So that's one thing that we can see here. And rental price and guest rating. So we might want to see that there is a slight relationship, but not a very evident one like we see here about this is with respect to guest rating, which is number of guests and stars. So slight effect with guest rating. So not a lot of uh, key things to take away from this graph as well. But as rating increases, there should be a price that is also increasing. That's one thing. Distribution of room times. We might want to observe that people booking entire villa have more number of bookings, while next comes farm stay and entire home and entire bungalow and the others. Right. So that's one key observation. Median rental price by room type. So if you see here, shared room in rental unit has a higher median price, while uh, the entire villa stays somewhere around here, right? Not a huge bookings on the room type, right? So another thing is distribution of accommodation and frequency. So not a lot of things to break down here. Frequency of number of guests at 16. Number of guests 16 have a higher booking chances at around close to 175, with 10 or 12 number of guests uh, having to book a Airbnb listing property at around close to 60, right? So that's one thing that this graph gives us an information on. Relationship between accommodation capacity and rental prices doesn't really show a lot of information. They all under their own uh, points. And another thing is superhost and non-superhost have slight bit of difference, but non-superhost properties have little more median value. So next, let's start off with a simple linear regression model, and we also have some few things like having to assign target column, that is the price, as a y value, and that's one thing. And we have a simple imputer strategy to fill in stars, and also one hot encoding method to transform categorical values to numerical values. That's one thing. So yeah, so we train the data set and we check the values of mean, absolute error, root mean square error, and r square. Similarly, we also want to compare it with other different types of models performance. So that's something that we do here. So yeah. and we see the set of results with mean square error having 766 and random forest having 632, gradient boost having a value of this. Most importantly, random forest is a best model that we can see here. Best model of R2 score gradient boost. That's the value that we see here, right? So gradient boost is a best performing model and has a strongest performance on this specific data set of 500 rows. So that's about all the data sets and the way that we train here. And next is we have a simple piece of code where we save the model into a joblib file, and also we can reuse it at a different point of time with the same set of imputer strategy and the one hot encoding methods. And we also are required to check this model with unknown set of data. So I have some amount of data here, and there are some estimations around the same, right? So yeah, this is about this project in a brief summary. Do check this code out and do explore this project on your own, right? Enjoy time working around and going around these project and data sets. Hope you're enjoying this project and all the learnings that we are doing in this playlist series. Please do post any comments or uh, any suggestions or any thoughts that you have for me in the comment section. Would be happy to engage in that. Thank you.